All right, let's take a look at what we did in class. 4.2, too big or not too big? That is the question. So we're still talking about Carlos and Clarita. And so we talked about in 4.1 how 12 dogs and 12 cats was too big, okay, when we looked at the startup costs. So remember, the idea was that if we took 12 cats and times it by 32, added the 12 dogs times 80, okay, and then we saw what that equaled, it became too big. Okay, it was equal to 1,344, which their maximum was 1,280. Okay, so we're going to explore that idea for a little bit further. So first thing we want to do is find 5 more combinations of dogs and cats that would be too big, higher than, so greater than 1,280. Okay. So this is pretty easy to do, right? And let's have cats be our x and dogs be our y. So we know already that 12 and 12 were too much, so we could do something really simple and just go 13 and 13 would definitely be too much. 15 and 16 would be too much. We could go, 20 and 21. There's a lot of different options that we can do here to make them too big, right? Okay, then it wants us to graph them. So if we look at graphing, 13 and 13 would be about right there. Okay, 14 and 14 right here. What else did we have? 15 and 16, 20 and 21. We could even do points clear up here, which would be 48 and 27. Okay, so any of these points clear up here would be too big. Okay, so that's too big. Now let's explore what about if it's too small, okay, or not too big. Okay, so what if it's less than 1,280? Okay, so how many cats and dogs would we be looking at here? Again, we can kind of do it pretty easily. I know if I have 1 cat and no dogs, or no cats and 1 dog, that's going to be less than, or 1 of each, or 5 of each even, okay? And maybe we double check that. 5 times 32 would give us 160. 5 times 80 would give us 400, right? So together, 560, definitely too small, okay? We could even maybe go as high as like 10 and 10, okay? So that would be 320 and 800. Okay, now we're pushing it, right? But that would be 1120. That's still too small. So some of them that are too small would be like 10 and 10. Okay, and then we can do a bunch down here. 2 and 1, 1 and 1, 4 and 2, 6 and 1. Okay, 12 and 3. Okay, so there's a lot there that are too small. Okay. All right, now let's look at the third thing we need to do. So on number 3, they now want us to find ones that are just right. Okay, so ones that are exactly 1,280. Okay, those ones can be a little bit more difficult to figure out. Okay, so here's one idea that I would use to do that. Okay, so again, cats and dogs. By the way, I don't think I mentioned it, but we're doing the cats as the horizontal, the x-axis, and the dogs as the vertical or y-axis. So the easiest two to find would probably be, what if there's just dogs? Okay, so if I have 0 cats, for the dogs, well then I would just take 1,280 and I would divide by 80, okay, which would tell me 16 dogs. Same way I can do what about if we had 0 dogs. So I take 1,280, divide it by 32, and we would get 40. Okay. Then we just kind of have to do some guess and check to figure out what else we could do. Okay. What other ones would work out? So like if we did 1 cat, okay, we'd go 1,280 minus 32, which would be 1,248, and then I try to divide that by 80, gives me 15.6. So that wouldn't work so well. Okay. So what if we tried 2 cats? 2 times 32 would equal 64. So then I'd go 1280 minus 64. Give me 1216. Divide that by 80. I get 15.2. Okay? So that one wouldn't work either. What if I try 3 cats? So 3 times 32 would be 96. So 1280 minus 96 would be 1184. Divide that by 80. We'd get 14.8. Okay. So how about 4 cats? So 4 times 32 is 128. So 1280 minus 128, divide that by 80, and we get 14.4. Okay, what if we try 5 cats? Okay, when we do 5 cats, we come up with 14 dogs. Okay, because 5 times 32 gave us 160. Okay, so maybe let's try counting by 5s for the cats. So let's do 10 cats. So 10 times 32 would be 320. Okay, 1280 minus 320 give us 960. Divide that by 80, and we get 12. Okay, maybe we see a pattern here then, huh? So if I did 15, notice as I go 0 to 5, 10, 15, these are going down by 2. So my guess is that would be 10. Let's try it. 10 times 80 equals 800. 15 times 32 equals 480. Yep. Okay, so that gives us a pattern. So 15, 20, 25, 30, 35, and we already have 40. So that should be 8, 6, 4, 2, and then 0. Okay, so those are basically our only possibilities, okay, or those ones right there. So let's graph those. Okay, so 0, 16 right here, 40, 0, okay. Then it was 2 cats. We had 14, right? Nope, I was thinking wrong. It's at 5, 14. So 5, 14 right here. Then 12 would be for 10, right? 10, 12. Then at 15, we were down to 10. 20, we were 8. 25, we were 6. 30, we were 4. 35, we were 2. Okay? All right, so there we go. Just rights are purple. Orange are too big. Blue are too small. So looking at that now, what do we notice? Okay, what do we notice about these different collections of points? Well, we can see that the too small kind of were in this general area, too big, this general area, and the just right are kind of making a line, aren't they? Pretty straight line, actually. So then it says write the equation for the line that passes through the points that were exactly. What does the slope represent? So if we look at this line, okay, we could write it in slope-intercept form. So our y-intercept is 16. So it would be D for dogs, or we could do it y. I'll do it both ways. Okay, we're starting at 16. And then what are we doing? Okay, well, every time we go down 2, we're going to the right, 2, 4, 5. Okay, so then we subtract 2 over 5, and that would be x, or dogs, or cats. So what that means, we're going down 2, so as we get rid of 2 dogs, or 2 pens, right, dog pens, runs, we can then add 5 more cats, pens. Okay, so it represents that change in number of dogs versus number of cats. So then, okay, Carlos and Clarita don't have to spend all their money on cat pens and dog runs unless it helps them maximize. So, are there more than one point that could satisfy this? Well, basically, all these would work, right? All these points. So really, all these points that are below would work. Okay, now, would a negative point work? No. So all these ones right here would work. Okay, what's a rule to represent that? How do we represent, taking this equation, how do we represent something that would work for that but also be less than that? Okay. Okay, well, the idea would be changing it from equals and make it less than or equal to that. Right? So y is less than or equal to 16 minus 2/5 x. Okay, that would definitely work, right? There's another way. We could also do this a different way as well. Okay. Well, if we think about it, remember that for the cats, we multiplied the number of cats, right, times 32. And then the number of dogs times 80. Then we added those together, and we saw if it was equal to 1280. Okay? So we could use that standard form of equation, right? Standard form, ax plus by equals c, in this case an inequality, and say that the number of cats times 32 plus the number of dogs times 80 has to be less than or equal to the 1280. Okay? We could change that to x and that to y. Okay? And it would still be the same thing, because if we simplified this, we get 80y is less than or equal to 1280 minus 32x. We'll divide by 80, and we get 16 minus, if we divided by 8, it would be 4 over 10, which we could divide by 2 again, so it would be 2/5 x. Okay? And so it's the same equation, just sometimes this standard form version is easier to use. Okay? Especially when we get to one like number 8. We can use that same concept. But just to remind you guys, this 32 times x represents the total cost of all the cat pens. Okay? The 80 times y was the total cost of the dog runs. And we knew together they had to be less than 1280. So using that same concept, we can then take a look at the next one. Okay? And we say cat pens are 6 feet of space, dog runs 24. We have a total of 360. So write an inequality to represent that. Okay? So we know our maximum is 360, that it's going to be the biggest piece or equal to it. Well, for the cats, how much space do they do? Well, 6 feet of space times the number of cats we have. For dogs, 24 feet squared of space times the number of dogs we have. We add those together, and there's our inequality, just like that. Okay? Now, is that going to be an easy one to graph? Maybe. Here's an easy way to graph ones like this. So it was 6x plus 24y less than or equal to 360. Okay? So if we want to graph this one, and let's make it this color. Okay? So a great way to think about how here, this represents if we only had dogs, right? So no cats. So it's like the cat section wouldn't exist, so you just have the dog portion. And down here represented just the cat portion, okay? And that part. So an easy way to do that is to think, okay, if I had no cats, it would just be 24 per dogs. So I could just take the 360 and divide it by 24, which would give us 15, okay? So that means here at 15 would be the max amount of dogs according to our space. Okay? Then, if we thought in terms that there was no dogs and just the 6 cats, again, you just have to divide by the space. So 360 divided by 6. So we'd have 60. So clear up here to 60, that's how many cats we could fit in the space. Okay? Then, connecting those two dots, I can see how that would work. And because it's an inequality, right, this space underneath would be included in that. Okay? And that's what we see when we get to this. So what do you think? What recommendation would you give to Carlos and Clarita regarding how many cats and dogs to plan on boarding? And what argument would you use to convince them that your recommendation is reasonable? So looking at these, I know that I can't use this portion, right? Because that wouldn't work for the space. And I also can't use this portion because that wouldn't work with the cost. So it's got to be something here. And I kind of like, maybe around that number. Maybe would be a good one. Okay. But really, any one of these at this point right here is probably the one I would do to it. And I'd probably go more equal, but that's kind of up to you. But I'd use this idea of this graph and what the possibilities are to determine what it is, how many you want to do. So I'd probably do about 6 and 13 maybe. 6 cats, 13 dogs. All right, so something like that. Okay, there we go.